thank you for joining us today. We're very lucky. We have 4 incredible panelists to talk about the future of artificial intelligence, a topic that I know is hot on everyone's mind. Just to introduce myself, my name is Adrian Monck. I served on the board of the World Economic Forum for some 15 years. I subsequently advised the world's first University of Artificial Intelligence in Abu Dhabi, Mohammed bin Zayed University of AI. And I write a newsletter on LinkedIn every week that goes to about 160,000 people. So that's me. With us, we have Aseem Datar, who is with Microsoft, but has an incredible career in tech and knows everything about how this technology is being operationalized and used. Henry needs probably no introduction in Frontiers House because he's the man who started Frontiers many years ago with his partner Camilla. And he's also a neuroscientist and a man who got ahead of the technology some 20 years ago with his neural project mapping brains, the Blue Brain Project, which was the first project to look at how intelligence really works in real biological terms. Anicka, artist. If you've been to Tate Modern and seen her incredible work, you'll know that she produces some of the most cutting-edge art imaginable, and she's got an incredible project that she'll probably tell us about, which is using AI to recreate her work and continue her work and her journey. Lila Tretikov has a career that spans almost every dimension. She worked for Wikipedia, she ran that, she helped relaunch it, she's been involved in AI at the cutting edge for several years and now heads AI strategy at NEA. So she has the most incredible perspective of where AI is headed. And we're going to hear from all of them. But I want to start, Henry, with you, because you're someone who 20-odd years ago was looking at intelligence, which we're now all taking for granted, if you like, in our pockets. And you were looking at it from a biological perspective. So have we now, are we where Sam Altman said we'd be? Is AGI just in our pockets, on our phones? Give us some idea of where the debate about the future of intelligence is right now in 2026.
Thank you. Thank you for being here. Thank you, Adrian. Yes, we have the world's knowledge in our pocket, but do we have the world's understanding in our pocket is another question. So I don't know if you know the movie Life. Do you know who knows the movie Life? It's about this spaceship, and there's a tiny little thread. It's like a translucent little thread. And the astronauts start to touch this little thread, and it interacts with them. And they're so amazed that they're interacting with this thread. And this thread gets more and more. Every time they touch this thread, it gets more and more intelligent. It starts interacting, and it behaves. And they realize, and why they're so curious, because it starts to learn from every interaction, and it becomes intelligent. There's no knowledge, there's no, encyclopedic knowledge, but it's considered to be incredibly intelligent. And in fact, it becomes so intelligent that it takes the hard line of intelligence, which is pure survival, and it, of course, destroys everybody. So it's a horror movie. But that's not what we want. But what it does point out is that we should think deeply about what is intelligence. Now, to contrast that, I think we should think first, just from a biologist's point of view, a neuroscience point of view, where we are today in the intelligence wave, the revolution, the AI revolution. So, I mean, it's clear that we've managed to find, and it's a massive breakthrough that allows us to capture all of humanity's knowledge. It's like encyclopedic knowledge. You look back at data. You find the correlations, you find the patterns, and you build these incredible applications and lots of startups, and you can do all kinds of amazing things out of it. You can find patterns, even of patterns of reasoning. So even all our human record of reasoning has been captured, and you can find patterns in these reasoning. And so the AI today can reflect the human record of facts, of reasonings, of all kinds of things that are in the human record. But it's a reflection of our intelligence. It's a reflection of humanity's intelligence. The question is Is it intelligent? Can we distinguish between the reflection of our intelligence, which is the patterns, and it being intelligent? It's clever algorithm, but so it's a correlation paradigm. It looks backwards, and it's batch. You have to capture data, train it, and then you can deploy it. It costs a lot because you have to mine for all these correlations to find these patterns. But and so you can also think of it as an observer. It's looking at the data. But are you really an observer? Do you consider yourselves observers? As humans, as animals, are they observing the world? We're not actually observers. You know, the only thing that comes into your eyes and your ears and your skin is a wavelength with an amplitude. You don't see pictures coming into your brain. Your brain compiles these pictures. You're actually a participant in the world. So you're born inside this world. If you look at a baby giraffe, it's born. Within 1 minute, it's standing up. Within 2 minutes, it's walking with its mom. And within 3 minutes, it's running in the savannah with its mother. There's no previous data. It's just calibrated to the cause and effect of this world. It's emerged in this world, and now it is running. That's cognition. That's the power. So the real intelligence that we have is actually almost, you'd say, 180 degrees, which is so remarkable, right? Because what today's AI is just so incredible, and you're going to hear for all these different products that can be built. But it's actually the opposite of what the brain does. The brain doesn't learn correlations. It learns cause and effect. And the reason why your brain only needs a banana a day and not a nuclear power station is because the causal relationship, the cause and effect that if you could only learn the cause and effect, it's a minuscule subset of all possible correlations. So it's far more efficient. It doesn't need to learn all these correlations and statistically try and work out which is the most likely. If you were learning correlations, you would be paralyzed. Because every minute that you go, you'd have to look at all the possible correlations between every single thing that's happening in here before you decide, okay, which is the best action to take. But if you learn cause and effect, you immediately cut to the chase. So the brain is totally different from the way that current AI is working, which is really remarkable, but it's also very exciting because it gives us a way of a new AI that doesn't need any historical data, that learns almost instantly because it calibrates with the cause and effect relationships of whatever environment it's placed in, whether it's data, whether it's a virtual environment, or whether it's in some kind of robotics. So that's, I think, is a very exciting next wave of AI that's coming.
That's a great way of starting our conversation. Lila, you're kind of looking at that from a commercial, investable point of view, what's coming next. Are there any startups you see where you think, wow, they're going to run on a banana and not on a massive data center? What are you seeing that's exciting you in this world?
Well, there are people are definitely starting to try and use different architectures. As we were saying, we are running out of compute. We're running out of power. I think it's a big problem for AI labs right now. We also have reached certain plateaus in terms of being able to just learn on top of already compressed human language, the history that we have established, right? We've learned on human history. So labs are starting now to investigate how to expand that, how to reasoning models, right, are actually looking at the embedded knowledge of how humans reason. They start looking at data about our relationships, etc. They're trying to spread in the vicinity of the models today, of the large language models today. And I have to say that even if we just froze development for AI tomorrow, we still have a decade of realizing that value. There's that much already there. Yes, it's a different type of intelligence. Yes, it's very alien to us. In fact, if you're a scientist, it's not exactly, people don't exactly understand how to tweak it. They develop intuition to it, but it's not a precise science. And at the same time, it's extremely valuable. There's a lot of value that we're going to be able to drain out of it. That value is going to have limitation. So and we're already seeing this in robotics. When you're looking at robots, if any of you walked the floor at CES earlier this year, in the beginning of this year, you probably saw these robots that are making beautiful dances. They're dancing and they're hanging out there. And then poof, they collapse into a little box, which they came from. And this is because the models of today, first of all, yes, they're very slow. They're not able to take into consideration all of the different possibilities. They break. They're very, very brittle. And if you talk to the top people in these labs, they will tell you that no, the current system, there isn't one big model that can drive these robots today. We actually have to, if you want to put a robot in production, if you want them to stack boxes in a warehouse or doing something useful, even just to move things at the factory, you have to glue together different models, and you have to make sure that they work for that narrow use case. It's not general. Right? Which means that we need a fundamentally different architecture. And this is, by the way, probably the biggest risk to what we're seeing in AI today. When people are talking about what is the big risk, AI bubble, etc., the biggest risk is an architecture that is fundamentally much more optimized, much more like human brain, and that all of a sudden takes all of the mathematics that's happening in large language model training, collapses that to something much simpler. If that happens, we don't need that compute. All of the infrastructure that we're building is going to become unnecessary. So that's what we're seeing. We're seeing companies that are starting to push there, and they push in that direction from different areas. There's your company that's pushing it from the architecture point of view. There are companies that are pushing at it from the silicon point of view. From the data point of view, is definitely starting to occur. The green shoots are appearing, but in the world of finance, all of the oxygen is being sucked up right now by large language models. It's really hard to actually see the allocations there, but it's coming. I personally believe we're going to have yet another wave, probably accelerated by robotics.
Brilliant. I mean, you're at Microsoft actually putting the future of intelligence into people's pockets, right? Along with some of the other big players. How is that going to change us in the next 5 to 10 years? Because I think in the room, who isn't using AI currently in any of their... Have we got any kind of like magnificent Luddites who are willing to put their hands up? No? Oh, I was hoping someone would wave a clog. But there you go. You've got an audience of converts.
I love all the believers in the audience, so thank you for that. Look, I think the thing that I'll say is, I think we're all starting to experiment with the early onset of this technology, and I think we are starting to look at use cases that are pretty obvious to us: writing documents, marketing copy, creating videos through the other kind of banana models, etc. So I do think that we're scratching the surface. One of the things that we're highly convicted on is the value that we can derive from this technology is immense. And as you said, even if we stop development, there's 10 years of value. The one field that we do believe is ripe for disruption is the world of science and scientific acceleration. If you look at the way research or R&D is done today, whether it's for chemistry, materials, or biopharma, just to give you an example, some of you might be from a pharma company, but if you spend about a couple $2 billion 10 years and out comes a drug, and that's capital intensive, takes a long time. Like, we've all had this recent experience of a pandemic, and how long did it take for us to sort of, produce an antidote for that? It took us a long time. So we believe that we can use AI and this technology to accelerate science and compress the scientific loop, as we call it. Like, how do humans or scientists do research? Like, science is non-linear. 1 step forward, 2 steps back, 5 steps forward. And I think, that's sort of the fundamental paradigm of what we're after, which is to compress that entire loop. And it starts with, reasoning over knowledge. We have vast amounts of knowledge. You then create a hypothesis. You generate an idea of like, hey, I think this is going to solve the problem. You then, run the experiment in a lab or a virtual lab or a wet lab for that matter. You then learn from that experiment, take that data, and then feed it back into your hypothesis, change your hypothesis, and you do that loop over and over and over again. What if you could compress that timeline? And so one of the things that we're after in Microsoft is building this platform called Microsoft Discovery, which helps accelerate and compress that timeline. I mean, just to give you a sense, we challenged ourselves and said, hey, can we go discover a net new molecule which is energy efficient and does the function of a battery, but using 70% less lithium? With our partner in Pacific Northwest National Labs, we were able to go from idea to battery creation in silico in 80 hours of compute. That's 80 hours of compute. I mean, and we looked across and created 32 million combinations of these net new molecules that humans are not aware of. And out came a battery. Now, of course, we're testing this battery through the lab. That still has to go through. But that's just an example. We built a coolant, which is a non-PFAS-based coolant in the chemical world. We built our own heat sink that is now going to empower the next part of the next set of devices that we're building with 30% more heat dissipation, all using AI and computation techniques. Like, that's just massive. So to drive this level of efficiency across chemistry, material science, drug discovery, even chip design, like that's the value that we can sort of bring to the table. And then to take that one step further, today there's a big disconnect between the dry lab, what you can simulate on a machine, and the wet lab. You wear a white coat, you go inside the lab, you run the experiment, but where does that data go? How do we feed that back in? And so there's data silos, there's model silos, there is different toolings that people use. So our whole vision is, can we apply AI, can we apply these techniques to sort of compress that loop and get to outcomes faster? And don't forget robotics at the other end. Can we control machines? Can we run these experiments, that are inferencing on data that exists? It's not about new data generation. And I think as we think about the future, there's the big wild world of quantum compute, which then helps us generate synthetic data that makes these AI models better, sharper, more accurate, cost efficient, generate the right amount of data from a training purpose, and then go compress that. So that's sort of how we bring the promise of technology to today in some ways.
I mean, that's a fantastically exciting kind of use case that you're outlining there. But I mean, human beings aren't just kind of thinking scientific machines. We're also creative animals. And, that dimension of us is maybe not so currently reflected in the world of artificial intelligence. I mean, Anicka, you're working very closely with AI. What's your experience of that collaboration and how the relationship between human creativity and AI can develop or is developing?
Thank you for that question. So I have lots of thoughts around intelligence, and it's not purely cognitive. So, I tend to work a lot in the sensorial realm. Through tactility and scent and, touch and sound. And that really inspires me in my approach to AI. So I really wanted to think about not just about what can AI do for us, but as an artist thinking, and also just, as a person who lives in the world, who's also utilizing these tools as well, is what kind of world do we want AI to reflect? And what kind of systems can they disrupt? And really thinking about a more holistic relationship to AI and a holistic relationship to the human as well as other non-human entities. So I just kept thinking that this future, that so many new futures are possible, and that the current paradigm is not inevitable. We can constantly construct and reconstruct and build whatever we choose. And I think there's a lack of imagination with that. So I think that imagination is really important right now in our relationship to intelligence, to technology. And so I was thinking about how to approach machines, and they don't have to be optimized. They don't have to be bigger, better, faster. What if machines could actually be our companions, and we could learn alongside them instead of being our overseers or some dominant force and having this, this anxiety of this binary anxiety of, being dominated or to have to dominate. And so when I did my project at the Tate Modern, I created these floating dirigible machines, and they were programmed to not optimize. They were programmed to be relational. They were programmed to be ambiguous, and they often just drifted and hesitated and encountered. And that's what I wanted to see and experience through AI. And with art, it is a lived experience, and it has to capture what it means to be alive, not just for us, but for life itself. And so it can't just be any one thing, whether it's theoretical or formal, and it has to be accountable to the lived experience. So that's what I was trying to do, to postulate about these ideas around AI. These machines in the Tate Modern, they also entered into the world through senscapes that I pumped into this vast space through these different sort of kind of sensorially historical difficult periods like the Black Plague, the Precambrian era, the Jurassic era. And so these machines were learning not only through the ultra-wideband sensors that I had installed in the space so that they could navigate the space and each other and the entities on the ground, but they were also learning about life through the sense that they were taking in.
I want to join that up to what, Henry, you said at the very beginning about the biological nature of intelligence. Are we in danger a little bit when we're thinking about the future of artificial intelligence of taking a kind of engineering approach to that future where we say it's going to be an engineer's intelligence that we produce artificially as opposed to a more holistic, more biological, more biochemical intelligence? Or am I going down a rabbit hole there?
Well, I think that you do have to have an engineering approach, otherwise you're not going to have fantastic, reliable products that you can deploy everywhere. But I do think that it does help you stretch the envelope to look at where the limits are. I mean, just to make a comment, why I appreciate Anicka's art is because art is amazing, but most of it is presented to you. The art that is made to present to you. But for me, Anicka's art is art that's born in the world. It's like when you watch it, you feel like it is emerging in the world. It's born in the world. And that's very much what actual intelligence is. You've got to become embodied. In neuroscience, we just call it embodiment. It's an old problem. It's a very difficult problem. People haven't really solved it because we haven't solved cause and effect. So being born in the world is very different from observing the world. And in a way, I don't know if you've seen, if you come tonight when there's a party, there will be a lot of Anicka's art on these screens. And it is really, you really feel like the art is it's coming into this world. It's not just being shown to you. So I do think that, we are moving from this sort of observer paradigm to the participant paradigm. And maybe that is more scary. It's what Anicka is saying, is companions. AI that is participants in the world. They are not just there to command or command us, but they're participants. And it's the only kind of, even from a pure industrial perspective, it's the only kind of robots. Imagine you wanted to send a troop of 12 robots to the moon to prepare a base. I mean, first of all, it's very difficult, even with quantum computing. Maybe you can help to generate a lot of surrogate data in order to analyze, and it'll still be expensive. And they have to explore. They have to learn in real time. They can't rely on data that they've accumulated. And humanity hasn't accumulated enough data on the moon. Imagine if they wanted to mine an asteroid. They've got to get to this asteroid. No human's ever been on an asteroid. We haven't recorded what's on an asteroid. So the robot's going to have to explore on this asteroid and discover things and experiment like what you were saying. But at the same time, there are lots of advancements, like using the AI to teach the AI to do the scientific method. And the faster we can get AI, even with the correlation paradigm, even with the current paradigm, if we can get them to exercise the scientific method, it's going to accelerate everything in science. And in the end, we will break through this barrier, and you will have these, I mean, I think there's going to be so many more exciting waves. We see the second wave is starting now, but we probably will have many more waves coming because of the acceleration of the current AI, which is just phenomenal.
I mean, Lila, just to bring you in on that, I mean, what are you seeing in that space?
I completely agree with that. I think we're going to, I call it a little bit more of an exploitation era. We've explored the language models, we've explored the transformer architecture, and we're sort of extending it in the different directions. And we're seeing actually in mathematics, it's very interesting, you're talking about sort of codifying a scientific method. We're seeing mathematical models that are taking formal language approach and actually now able to solve some of the hardest problems, able to solve problems that were never solved before, right? Even with the current techniques, and that's just going to continue. In material sciences, we have companies that are developing new materials, you know, in 1/10 of the time that normally it would take. Similarly with biology and chemistry, similar things are happening. So I think that is absolutely coming. And just to think, you know, I started my career by working on a human genome project. And I built the very first genomic browser. It was a very simple Markov chain, you know, extrapolations. I mean, we're way, way, way beyond that. We can actually in silico model some biological substrates, right? And we can explore them purely within the computer, right? Before we even try to do it in the wet lab. So we're rapidly approaching that space where we can actually start to take even the current technology into the physical world. We're doing that today, and there are companies that are actively working on that. It's very exciting.
And Aseem, you know, you're in the business of industrializing and operationalizing this intelligence. I mean, are we able to keep up from a regulatory point of view with where things are, or is some of our approach holding things back? Because you talked about the testing of it. All of our testing protocols in biology, in medicine, everything else are incredibly tight, incredibly strict. We saw that during COVID, how they could have been compressed much, much further. Do you think we're kind of, from a government and regulation point of view, keeping up with these changes?
Yeah, I mean, I'm always a glass half full kind of guy, right? So I see that as opportunity. I think what we're seeing is, you know, everyone's pushing the limits of what we're hitting up against today, like whether it's regulation, whether it's compliance, you know, whether it is like rethinking, you know, the way of acceptances, right? I think one of the key things that we believe fundamentally is that technologies like AI, technologies like quantum are all about enhancing humans, and they're all about augmenting humans, right? And there's a reason why, you know, I joke that we call our AI solutions co-pilots, not autopilots, because they're not going to do it by themselves. Like, you still need human reasoning, you still need steering, you still need intervention. And the same thing is true of regulation, right? Like, even if you take a body like an FDA, they need to really think through on what does it mean to sort of accept the first AI-generated drug when it comes through. What are acceptance tests? What's the data that has been used to sort of train these models and use these models? I also have a firm belief that, you know, models are not the solution to everything, right? I think people generally mistake it and say, oh, let's just ask the model. Well, great. What's the model made of? What data is it trained on? Like, you know, are there edge cases? Are there things that could go wrong? Are there places where they could hallucinate? And there are realities where these things might happen. So I think we need to have a fresh approach to regulation, but also look at it from the perspective of the regulation is not just following a template, it's not just a rule, but we are constantly even, evolving how we think about these technologies. I mean, I think we were just at the back of the room, we were talking about understanding a single cell. We're still sort of at the atomic level. We're still trying to understand atoms and how they interact with each other, even in the world of quantum. So I think we need to have a constantly learning kind of mindset, whether it's science, whether it's productivity, whether it's robotics. And so composing all these things together is going to be the challenge in front of humanity. Like, how do we actually put the right guardrails, but at the same point of time, use this really as wind behind our backs and not think of these as, oh my God, it's a roadblock. So I think you got to learn, as we said, and navigate and figure our way through. Going to Mars is an excellent analogy, right? You can put a robot on there, and even if you put a human, they're going to figure it out. They're not going to say, oh, I know it all. They're just going to try and learn it all in due course of time. And as long as you take that mentality of using technology to have a learning mindset, I think we'll be in great shape.
And Anicka, is that a mentality you bring to your work? A kind of collaboration rather than a kind of tool-based approach? Is that something that resonates with you when you're working with AI? And you're currently, I think, working on a project which is going to memorialize some of your art. I mean, how...
That makes me sound like I'm near death.
I know. I couldn't think of a nice way to say it.
Yes, I mean, hearing everyone here on the panel, I can't help think about what the philosopher Yuquay talks about, techno-diversity, that there's no one universal path with technology, that there's a possibility to have many different cosmologies and different ways of living, and that technology can embrace that. What I don't like is seeing this singular narrative, and we just have to optimize uncertainty, and everything needs to be resolved immediately. And then just talking about the drawing from the wisdom of biology, those are some of the tools that I work with in my approach. But what you're intimating, this project that I'm developing, it's a project I started in 2019. I was actively thinking about how to continue to make art after my biological body ceases to function, and started what I at the time called, in a really very not a good title, the post-death studio. So I was thinking...
I think memorializing's a bit nicer than that, actually. I mean,
you were the positive in the room, right?
And I just thought, okay, I have art ideas for 100 lifetimes. How can I continue to make art after I'm dead? What should I do? So then I started this forensic study into the creative DNA of my studio, and really started to, understand, what is creativity? How do we actualize it? And there are so many components. And thinking about how can we teach AI creativity. I mean, that was low-key part of the goal, right? And so I thought, okay, I could have some digital assistants, and that's a research project I started a couple of years ago, but now it's sort of evolved and bloomed into really endowing artworks with cognitive abilities, that they could be not just an exquisite original artwork that can put you in the present and give you an incredible lived experience, but it could also be your companion, and maybe you could even speak with it and have conversations. And so there are a lot of exciting explorations that I'm embarking on right now.
I love the idea that we could maybe one day talk to Rembrandt's Night Watchman or something and have that kind of conversation. That'd be brilliant. Lila, when we were speaking just before coming in, you were talking about some of the roadblocks, and you mentioned them here that we're running up against. But we're also running up against ways of solving some of those roadblocks. What are the most exciting ways you think we're kind of pushing the boundaries beyond the compute, beyond the energy kind of barriers that you see?
Well, I think we're seeing sort of new architectures evolve, which is really interesting. you're working on one of them, you should talk
Yeah.
about that, which are much closer and much more optimized towards how humans learn, like we were talking about, right? If we wiped out all human knowledge tomorrow, it would be really hard, right? But humans will rebuild it. I mean, look how far we've come, and the reason we're accelerating is because we have that base. But it's our intelligence that drives us to create more faster and learn more faster. Better models can do that. Right now, the models are purely statistical. They're very, very heavy mathematically. They recalculate the same operation over and over and over again. Right? That's very, very inefficient. So, in parallel, the current technology chain is being massively optimized and then extended. So what people are doing, they're using, even though the model is looking backwards, they're using it to actually sort of look forward and run predictions ahead of time and then look at which ones of the predictions is most successful towards its outcome, its loss function. By the way, humans do the same thing. We're constantly running simulations in our head is what is going to happen the next minute. And we're massive prediction machines. So we're trying to mimic that. We're creating agents, just kind of like what Anicka is doing. We're creating many, many, many agents. Right now, they're digital, that are able to explore the world and do different things. And the next phase is helping these agents collaborate together. How are they, because if we are each one of us as individual, we have our own optimization function. We're all optimizing towards our own personal success. But when we work together, we can optimize towards a common goal. We're teaching machines to do exactly the same thing. And right now, they're purely virtual, but over time, they're going to become more and more physical. And the last one is actually living in the physical world, right? You can express this as robotics. And by the way, there's a lot of companies that are experimenting with sort of more toy-like robots. The company here, Hugging Face in France, just I think a couple of months ago, shipped one of the early ones. Being in the world, but not only in the robotic sense, in the sense of being able to take sensory input and now embed that into the model and teach the model with all of that. And by the way, computers, even though, if we were robots, robots have fewer senses than we do because it's just too hard to put all of those senses on them. But overall, we can actually have much more sophisticated sensory input to the models because we can measure much more. We can see, technology can see ultraviolet light. It can measure, the speed of wind, et cetera, right? So these models can be much, much more sophisticated and much deeper over time. So I think we're both exploiting the technology that we have already built, and that is going to yield enormous downstream results, and we're exploring new areas that are adjacent to what we already have.
And Henry, you are building some of those architectures with some of the work that you've been doing.
Yeah, I see that the future is going to be a combination and a continuation of all of it. So, for example, you would have, and I don't think this is going to go away, this first wave is only going to get bigger, because it is a way to capture knowledge, and it can capture much more knowledge than any of us human beings can capture. We can capture all of humanity's knowledge. You have encyclopedic knowledge going back as far as the human record. And it's a great way to capture the knowledge. It's very expensive, and the updates are expensive, but it is much better than try and get one brain, even if one built a brain, to get one brain to hold all that knowledge. So you can think of it as like retrospective AI and forward-looking AI, which would give you the interactivity. And the interactivity is really the part that is going to give us machines that are seamlessly interacting and being able to understand. So this is a kind of knowledge AI revolution, and it's going to be combined with an understanding AI revolution. And a lot of the technologies that Lila is talking about are sort of knocking on this door. How do you get to understanding? There's a lot of academic work and scientific work that is based on you can only get to understanding if you understand cause and effect, counterfactual reasoning, and so on. It's not understanding if you take, it's a reflection of understanding if you take lots of examples of all human reasonings, and you can get superhuman reasoning. It's not that today's AI cannot do superhuman reasoning, because it's taken all your reasonings and everybody else here in Davos and everybody in the whole world, and it's captured those reasonings in text, in words, and sequences of words. And it's found patterns that this reasoning works best in mathematics, and this works best here, and so on and so forth. So that's why we feel that this AI is so incredibly intelligent, and we feel it's reasoning. Well, it's capturing the best of all of us. And that is superhuman. And that will continue, and it will get more and more sophisticated. There's a lot of discussion of solutions where you do recursive, where the AI sort of argues with each other to keep distilling out the best and best of reasoning. You combine that with a scientific method, the AI is going to get incredibly powerful just with the current technology. But the problem that really is an unsolvable problem that has to be solved is, you can think of, you have the sound barrier, you have the light barrier, you have the real-time barrier. Now, at real time, you run out of data, right? I can't wait 10 minutes before I reply or before I say the next word. So you need a lot of historical data normally, but as you get to real time, there's no more data. So you have to have, and that's true intelligence, when you can react with zero data. So you have to continuously learn on what's coming in at that moment in time. And that is what biological organisms do. And so I think if we can unite these two, the backward data and the real-time continuous learning, then you will have a sort of the beginning of a framework for true intelligence that's going to be very much more like what we do, but superhuman, because it's going to have all the superhuman knowledge and probably superhuman capabilities to act on the world as well. So this is going to be, I think, is going to be an intelligence which may be scary, but it's going to be much more participant. And I think that we're going to be challenged in the relationship we build with this kind of intelligence, which is something that Anicka has been thinking about very deeply. Not just sort of binary, control it or be controlled, but to participate with this kind of intelligence. So in INAIT, the company we have, our products are called, in a range, they're called the complete range, because we think that we're kind of completing the retrospective AI with the prospective AI. And maybe I shouldn't say it here, but the one would be species complete. So, because it is possible to build the brain now, and you will have different species. So you'll have digital bird brains that you can put onto drones and insects, and you will have all kinds of brains. So species complete, where you will be able to have them behave and act as a species.
I mean, I think that what you've seen in Davos this week, there's probably some brains that shouldn't be maybe dealt with like that. But it's interesting kind of listening to all of you who are very much at the edge of where AI is. And we haven't really mentioned AGI, because it's almost as if that conversation has kind of been left behind a little bit by where we're going. Do you think that where we are right now is we're in the industrial phase of the LLM movement, if you like, and that some of the AGI stuff reflects a little bit of marketing speak that went a little too far?
Yeah, I mean, I would typify it as, I think it's oversimplifying to call it the industrial age of AI in certain senses, and I'll explain why. I actually think that there's a reason, the stage where we're at is not automation. Automation is taking something, make it better, improve it, 10% better, keep saving, keep saving, keep saving. We're a little bit beyond that, right? We're now gone to the point of like intelligence or knowledge, hypothesis, reasoning, etc. And I think all these terms are basically saying that you can develop mental models, and mental models, just like humans would sort of use to sort of reason over something, you can now have, intelligent systems that would act on these mental models and debate and, argue and sort of come up with the best possible solution at the right possible time, for the problem stated. So I think we're a little bit beyond the industrial age of deployments, as I would like to call it. And I think we're starting to see, biopharma, executing on what, like, towards the vision of, like, is there an AI generated drug, new chemicals? We talked about silicon design, robotics. So I think we're a little bit beyond that. I do want to sort of also hint at the fact that I think what we're starting to see is scratching the surface of what the technology can actually deliver on high value scenarios. I don't think we've completed the loop, and to Lila's point, there's so much we can still do with AI that we're just trying to learn and figure out, like, how does it work in my existing workflow? If you take a scientist and if you tell them that, oh, I've got this amazing new thing, and all the thing that you did in the past, like, throw that out and go do this new thing, and it's a black box, you ask it a question, it gives you an answer, they're going to say, you're crazy. I want to know why you're telling me the answer. Like, what's the synthesis? What's the reasoning behind it? And so one of the things that we're very, very heavy on is we actually look at different scientific papers, and if the AI is guiding the scientist to go take a certain approach, we want explainability and transparency. We go down to the citation level of papers to say, here's the 5 things that I've learned because of which I'm giving you an answer. And I don't think that that's AGI either. So I do think that we're somewhere in between. But like I said, I'm an optimist. I look at all these scenarios that we can go solve for. And so I think we're fast moving towards those. But there's still, plenty of opportunity to go tackle these high value scenarios.
I'm committing the cardinal sin of moderators, and I'm looking at my watch, realizing I've slightly gone over. But I just want to bring in a last word from Anicka, and then have I got time for one very quick thing? Okay. Annicka, can I just ask you, from what you know about where AI is right now, what do you want from it as an artist? As someone who's got a humanist perspective on this technology, what do you want most from it?
Firstly, I left the Church of Humanism like 7 years ago. And what I mean by that is I've been questioning the unstable category of the human for quite some time. And I think what we think of human is not really what we are. And I think that that ties into what I want from AI is I want companionship. I want to be interacting and relate to a different kind of intelligence that we haven't really yet experienced on this planet. You call it alien intelligence, but something that's really different, that's not drawn from pre-existing data, that is essentially recombining what exists that we've put out into the world, and that doesn't truly feel like a collaborator or all that creative to me. What I want from AI is access to a really different kind of intelligence that doesn't come from us.
That's a brilliant answer. I mean, I actually think that's a great place to end our discussion. Big thank you to all our panel. Thank you very much.